Hello, welcome to our little corner on the web, where we hope to develop and nurture a love for math. Today, we will go over question 4 in part 3 of the recently concluded 27th PMO qualifying stage. Thank you to the organizers for freely sharing the questions. Question 4 asks, how many ways are there to write each integer from 1 to 6 on a different square of a 3 by 3 square grid, such that the consecutive integers are on adjacent squares and 1 is not adjacent to 6. Note that adjacent squares are squares that share a common side. Okay. For those of you who want to try it, this might be a good place to pause before proceeding to look at one possible solution to this question. Okay, proceeding on. So let's dive in. So it basically says that we have a 3 by 3 grid. And that 1 and 6 are not beside each other, but the other integers are on adjacent squares. Okay, so if 1 is here, we know that I'm going to shade a few cells here. We know, or we can deduce that the circles that are shaded green right now will be where the even integers have to be, because they have to alternate as they go around, or as if they're adjacent, they have to alternate in odd even. Okay, so the non-shaded are odd and the shadeds are even. So that means 6 can only land in one of two squares, either here or here. Okay, we only actually need to look at one case because the other case is basically symmetric along the diagonal. Meaning if we find a case where we can reach the bottom middle square, there's a similar case that reaches the furthest right column middle cell, right? Okay, so we can actually find out or trace the paths that come from 1 to 6. So for example, if 2 is here, then there's a path that goes 1, 2, 3, 4, 5, 6. That's one path. The other path is 1, 2, 3, 4, 5, 6. Okay. There's a few more paths. 1, 2, 3, 4, 5, 6. Okay. And there's an even different path that goes through that also. 2, 1, 2, 3, 4, 5, 6. Okay, so those 4 paths exist if the 2 is where I've drawn it. Okay. Oh wait, I didn't draw one of the paths. Okay. Those are 3, and the other path that I was thinking of, let's put it in black, is 1, 2, 3, 4, 5, 6. Okay, so those are the 4 paths if 2 is there. So just so that we don't get confused, I'll draw a different square here. If 2 was in a different cell, from 1 being in the corner, and let's say 2 is here and 6 is still here. Okay. It turns out for this case, there's only one possible path, which is 1, 2, 3, 4, 5, 6. Okay. There's no other way to draw it because if we go down here, we're stuck and we can't get to that 6. So for this case, where we started with 1 on the corners, there's 4 corners to choose from. There's 5 paths that we've seen go to the lower middle box, this box. Okay. And again, by symmetry, the 6, if it was in this box here, we would see all the cases. Just sort of imagine flipping this square we have now along this diagonal. Okay, so basically times 2. So there's 40 cases if we start at the corners with the 1s. Okay. Okay. So now let's look at what happens if we start at one of the middle cells on the sides, like this one here. Again, by shading, we can sort of deduce that the cells I'm shading right now are where the even number should go. So the 6 can only be, because it can't be adjacent, here or the other, lower right middle. Sorry, lower right corner. Okay, this one. Okay, so again, by symmetry, we can sort of think of just flipping it across this. So we only need to look at one case. Okay, so we'll look at the case where it's on the lower left. Okay, and see how many paths again we can trace to go to that cell. So if the 2 was here, there will be one path like that. There would be another path like this. Okay. There will be yet another path that goes all the way around. Okay. So that's 3, right? Okay, let's see where if 2 is positioned in a different place relative to the 1. So if we have 1 here, 2 here, 6 here, there's only actually one path, which is this. Okay. And then there's another option for 2, which is for the 2 to go right in the middle of our square, 3 by 3 square. So if it's 1, 2, 6, there's also only one path for this. Like that. So there's again 4 corners to choose from. Sorry, 4 middles. 4 middles to choose from, namely this guy, this guy, this guy, and that guy, where we could have placed the 1. Okay. And the 6 would be the appropriate offset from that. Okay, so there's 4 ways, or think about it as rotations of this square. So there's 4 times 5 paths. Okay, and as I said, you can think about the mirror cases mirrored along that line. So there's 4 by 5 by 2 cases where we start at some middle cell. Okay, middle side cell. So again, this is 40. Okay, so hopefully it's obvious that we cannot start with 1 being dead middle, meaning in this location, we cannot start with a 1 there because there's no case where 6 will not be adjacent to it if we start tracing paths. So the total number of cases here is 40 plus 40, or total of 80 cases. Hopefully you found this solutions helpful and educational. If you did, please do hit the like button and subscribe. Thank you for watching.